Hey, what's up, dudes? Got a problem with this HVAC system. It is coming on, but it's not heating the house. I think the fan is at fault, but I'll show you how we can determine that. So right now, the switch for the HVAC is off, and it's been off for a little bit. It's still kind of warm because it's been on, but it's not distributing heat throughout the house. In other words, it's basically staying on upstairs at the thermostat. The thermostat seems to be calling for heat. I've already had the thermostat off the wall, and I've checked it to make sure that it's actually closing a circuit whenever it kicks on, and it is closing that circuit and calling for heat. So with the thermostat on at the moment upstairs, I'm going to flip this switch. We'll see what happens here. Oh, here's the problem. I don't have this. Okay, we got to flip the switch here. This is the door switch, and it has to be closed. Okay, so here we go. We've got this fan here kicking on properly, and we've got fire starting. And what's supposed to happen is after a minute or so of heating up the box, it's supposed to, the thermostat up there is supposed to send a signal that's warm enough, and then this fan will kick on and start to distribute the air throughout the house. But that's the part where I think everything is falling down. And the fire seems to be doing fine. We don't have anything that's excessively jumpy or anything like that. You saw it kick off right there? Okay, so I think it kicked off because it's detecting that the motor down here is not running. So basically what would happen from this point is this would continue to run until it shut off. And that's basically it. So we'll let that go. Okay, this is the run capacitor for this, or the start capacitor actually, for this fan blower. I don't think it's the blower. I think it's probably this capacitor. Talk about old. Look at the color difference there where the strap was. 10 microfarad, 370 volts. This is a non-polarized cap, so it doesn't. The polarity shouldn't matter on it. What is this one? This one's 1 microfarad. I misread this. I misread this one. This one's 1 microfarad, not 10. So this one's not going to work. I'm going to have to do something else. So let me see what I can do, because that, like I said, that right there is a 1 microfarad, not a 10. Okay, so I don't have a proper capacitor on hand, but I do have some Sprague Adams at 20 microfarad, 500 volts. The old capacitor was 10 microfarad at 370 volts. This is actually measured in the on my tester. It measured 12 microfarad total. And it should be at 500 volts still. So we're going to try this right here, and it's non-polarized because I've taken the negatives and soldered those together. So this is a non-polarized capacitor now, and we'll hook the leads up to the two positive ends, and that should, fingers crossed, get us going. We'll see. Okay, so this is just going to be a temporary solution until I can order a proper capacitor, but all right, let's see how it goes. We'll see how it goes. Okay. Once again, we've got fire. And the blower motor should come on here in a minute if everything is working properly. Fingers crossed that temporary solution right there works out and doesn't explode. We'll see. I mean, that's a start capacitor, so it shouldn't have to operate even for more than a couple seconds. At least I'm pretty sure that's a start capacitor on this motor. It should be just a start, not a run. But I don't know, honestly. Well, either that's going to shut off or this is going to go. One of the two. There we go. There it went. Working now. Okay, so that's all it was. And actually, that capacitor right there that I made is that's a higher rated capacitor than the one that came out of it. It's a 500, whereas, like I said, the other one was a 370. So it's working, and that would continue to work if I want to leave that like that. So, you know, we'll see. We'll see. Anyway, so that's something you could do if you want to get by. If you do amp repairs and stuff, you know, and you have some capacitors on hand, or if you have an old amplifier and you have capacitors on hand, you can wire them like that. So basically, you'll tie the negatives together. So if you can find something that's rated above what you have, then you can always take. Basically, you want to double it. So whatever your current capacitor is rated at. So this one was a 10 microfarad. So I wanted to double that value up to like a 20 microfarad, or 22s are fine. Also, that's in the same ballpark. So you get that value and you tie them back to back. So tie the negatives together and then use the positive leads to tie into the system. And then that should work, and it is working now, so everything is good. We're all good. I'm going to go ahead and release this door, and I'm going to release that switch. We'll replace this door. Okay, guys, so this thing still has a problem. I'll show you what's going on with it. Right now, I've got it switched off with the switch up here. The capacitor that we put in there didn't solve the issue. It's still short cycling. And I'll show you exactly what's going on, the symptoms. The thermostat upstairs is calling for heat, so it's already on upstairs on the thermostat. So if I kick this on, everything should start up. Now the blower motor will start temporarily, but I think what's happening is there's a problem with the motor itself. I pulled the capacitor out. I went and tested it out of circuit later, and the old capacitor seemed to be okay. Now it was a couple of microfarad off. It had drifted upward a couple of microfarad, but I don't think that would have caused the exact issue that we were seeing here. And this is what it was doing before as well. So the capacitor didn't change what was going on. But let me show you what's happening here. We'll turn the furnace to the on position here. Now what's going to happen is we'll hear it start up. Let me make sure actually. Okay. Now the door switch is taped to on. So what's going to happen is this is the exhaust fan, and it's going to start up just fine. This motor will also start up just fine, and it will start running for a bit. And what we're going to do, I'm going to show you what's going on. So with my meter, we're going to test the amps that is being pulled through this wire. So this is going to read 1 milliamp per AC amp. Oh, and incidentally, this probe, this Fluke probe right here, I got this at a recent auction. I got this in a lot of stuff. This is a Y8101, so it should come in handy here. But I'll show you what's going on. So let's go ahead and turn this thing on. There we go. Okay, there's our exhaust fan. Starts up like it should. Now we should get fire. We'll get flames here. And we do. We don't get really any appreciable rollout or anything like that. So everything's looking good on the flame front. And here in a minute, we should, after this warms up, it should kick on the fan. And the fan will only kick on whenever the temperature gets up to a certain degree. So here is our, this is a limit switch. This is the fan limit switch. Now what this is going to do, as this box heats up, this fan limit switch is going to rotate. There's actually a long piece of metal that sticks into the heat exchanger, and it's composed of like a coil of it's kind of like flattened wire, and as that flattened wire gets hotter, it rotates, and it rotates this right here, which is the switch on the outside. And I have this set where it's going to start up once the temperature reaches about 90 degrees or so on inside the exchanger. So you can see it. I don't know if you can see it or not actually, but hopefully you can see this rotating. It's rotating very slowly, and here any second now the fan's going to kick on once it reaches here. Actually, once it reaches 120, excuse me. So not the first notch, but this second notch. So it should be any second now. Should go. Is it gonna go? There it goes. There it switched. Okay, so now the fan actually is running. It's gonna be hard to see, but trust me, it's running. But it's kind of running slow. And what's happening is it's running at this reduced sort of speed. And meanwhile, this box is still continuing to heat up, the heat exchanger. So while this heat exchanger heats up and this fan is running slowly, it's going to eventually trip the limit switch. Once it gets up to 200 degrees, it's going to cut the heater off. So these are the symptoms that we're looking at. And right now, the fan is running, and I'm not, let's see. There we go. So this is what we're reading. So we actually are reading something on this. So if we take that off of there, we're reading something, and then it just clicked off. That's because it went over the limit. Now, I think this switch is okay. I don't think that switch right there is at fault. I think what's going on is this blower is not blowing fast enough to cool down the heat exchanger. Now, it does this with or without the cover on here. So, you know, I know you're going to say, well, put the cover on, dummy, and it'll cool it down. Yeah, it might do a little bit better, but that's not it. And also, I already checked the filters, and the filters are not clogged or anything like that. But what's going to happen is this is going to drop back down. You see it's dropping in temperature right now because the fan actually is still going. The fan is still going at this reduced speed. So it is dropping the temperature in the box, in the heat exchanger, back down, and here any second now it's going to fire back with some more fire. There it goes with fire. Okay, so now it's going to fire up more, and then it's just going to raise, all it's going to do is going to raise to the temperature of 200 degrees or so inside the box, and it's going to trip this switch again and shut the heat off. And it'll continue to do this cycle kind of again and again until I think it reaches a maximum. I don't know what the lockout is or what it's 90-second lockout, 5-minute retry on that, but I'm not sure what that pertains to exactly. But what ends up happening here is it goes through this cycle a couple times, and eventually this fan just shuts off randomly, and it shuts off at a point in the cycle where it just makes no sense. There's no visible switch or anything that shuts the fan off. It just seems to shut itself off. In other words, it's not being shut off by the fan limit switch, if that makes any sense. So right now, the part of the cycle that we're in, you can see the fan is still running because we've got some, we've actually got some AC current being drawn through the wire down to the fan, and plus the fan is on. I can visibly see it on. But what happens with this, if you'll look at it, it starts to, the whole time that this thing is on, it just reduces in current draw. So the current diminishes and diminishes. They're kicked off again, the heat, because it reaches the limit. So so this is why it just keeps short cycling. So it reaches the limit, shuts the fire off, the fan keeps going, because of course it's going to, because the system wants this box to cool down. So it's trying to get this box to cool down. And it is doing that job, but just very slowly. And we'll see right here, 10.82, 10.78. You see that it's just reducing and reducing on the current that we're seeing being drawn through that wire right there. And it will reduce down to about 9 or so. It'll be, I think, 8 point something or 9 point something, and then the fan just basically shuts off at that point. It'll just keep going down, but it will remain on throughout the whole cycle until that happens. So it technically right now it's heating the house, but it's not working properly. It is heating the house and it is blowing air up through the ventilation system into the house. There it goes. We kicked on again. We've got more fire coming back. It's like it's going to try to heat it back up and try again. But once again, it's just going to heat up to the 200 degrees and then switch off again. We're still diminishing on the current, but this will just continue to go back down. There it clicked off again. So this is what, the third or fourth time that it's done it. And the problem with that is the rest of it will continue to go. So the fire will kick back on without this fan, and then it'll just heat this box up to the point where it shuts itself off again, and then this fan is the only thing that can cool it down. So it takes much, much longer for the exhaust fan to actually pull the excess heat out of this, or for the heat to dissipate into the surrounding environment. And this is not the way this is supposed to run. This measurement right here is just going to keep dropping until eventually that fan is going to kick off. It'll go down, it'll go from, you know, having 9.5 or 8 or something, 8 point something to 0, because it'll just stop at that point. I have pulled this blower motor out of this machine, and I'll show another video if you want to check that out up here. Recently, I pulled this thing out and blew it out, and there was so much dust and dirt and debris and everything inside of that squirrel cage. And inside the motor, okay, so what kicked off there? So that kicked off again. So again, we went over the limit. Our fan is still blowing for now, but any second now it should kick off. Probably within the next minute or so, it's going to kick off. And right now, it's, you know, it's trying to heat the house up to the heat that I designated up at the thermostat, which was like 70 degrees or whatever, and it just can't do it. It can't get up because the blower motor is not strong enough to blow enough up through there. It just can't get enough air flow, not only to keep the box from heating up and overheating, but it can't get enough into the vents to really heat the house up properly. You know, it'll raise the temperature some, and it'll feel like it's a little bit warmer, but it's not doing its job efficiently, and it's not doing it in its entirety. But I want to watch this because I want to see what it gets to before it actually shuts off. And we're getting close. I think, like I said, I think this was down to about 9 or a little below 9 before it shuts the fan. Just the fan shuts down. I think what's going on is the fan is struggling to get up to speed and to stay up to speed because I think it's just worn out. I think it probably needs to be disassembled and rebuilt or lubed or whatever. And that should have really been done when I took the thing apart. But all I did was basically clean out the squirrel cage and everything. But we'll see what it stops at. Like I said, I know it's going to stop any second now. Yeah, if you came in here, there it went. There it went. It shut off. You see it? You could actually hear it shut off. It's still moving because it's still got some momentum, but it's off now. So what's going to happen now is this is going to kick back on. So, well, it kicked off just now, but there's going to be nothing to draw down the heat because this won't be blowing at all up through the box. So the heat is going to basically keep going up at this point, and you'll see this continue to turn until it gets to basically its maximum. But there's no more fire, so it's not going to continue to heat up. The switch is doing its job, so I think the switch is fine. So right now, the only thing that's drawing down the heat is just the, the natural dissipation into the surrounding air, and up into the, up into the house. And also, this fan right here is doing some of the work as well, pulling the exhaust fumes out of the pipe and outside. And that's taking away some of the heat too at the same time. But you can see this, our limit was here, and it's supposed to meet this little notch right here, that little limiter switch, but it's way past that. It's gone all the way up now, and it's as hot as it really ever will get, this heat exchanger right now, which really isn't good for it. So you don't want your system to keep running like this. This is not the way to run a system. And if you didn't know any better, you might think, oh, everything's working, the blower motor's working, so it can't be that, it can't be the, and the exhaust is working, the switch is working, it's doing its job, the fire is on. You might think everything is okay at first, but not when you examine it a little more closely. So what we're going to do, I'm going to let this cool back down, and we'll shut this thing off. I'm actually going to leave it running for just a bit because I want the exhaust to help continue to run and help cool it down a little bit. But once that cools down a little bit, starts going back down, we'll shut this off, and then we'll pull that blower motor out and change it. Now I've got a new blower motor. We'll go ahead and open it. This motor is from Vevor, and it is I think it's a 3rd horsepower, and that's the only thing I could really find. The selection for blower motors is actually not very good. There's not a lot of them out there, and I've had good luck with the other stuff that Vevor, for instance, Vevor sent me recently a ultrasonic cleaner, and I thought the quality of it was pretty good. And I also have one of their stills, and the quality of that was pretty good. So I felt pretty good about ordering this, and this is not a sponsored video. This is I actually paid for this, so we'll see how it goes. Hopefully it doesn't screw me. But this one also, the reason I got this is because it came with the mounting brackets. It came with everything you need to mount it, basically, and it also came with the capacitor. So I shouldn't need to get anything else. The capacitor on this is a 5 microfarad at 370 volts. And yes, it's possible that there's an outside chance that that's all I needed was a capacitor for this. But I don't know how long this motor's been in here. It hasn't been changed since we've lived here, and it's been 7 years. It's probably, if I had to guess, I would say this is probably the original motor for this furnace. That's my guess, and that's probably puts it at going on almost 50 years old, 40, 45, 46 years old. So it's probably time. Just go ahead and change the thing, you know. And it's made in China, of course. Everything is now, so you're not going to get away from that. But we've got this is a dual rotation, so it'll go clockwise or counterclockwise. And one thing I forgot to do was observe which direction the current motor is going. So I might have to actually turn this thing back on briefly and just get a look at which direction it's going. 1/3 horsepower, 110 to 120 volts, single phase, 60 hertz, 4.5 amps, 1075 RPMs. It's 4-speed, and the capacitor is a 5 microfarad at 370 volts. And it is it's a thermal protection. And see, that's what I think is going on with this current motor. I think it's entering a thermal protect, and it's just overheating, basically. And going into thermal protect mode on the actual motor, because there's an additional thermal protect on the motor that's not listed on the schematic. Actually, I'll go through the schematics separately. I'll sit down and show you why I think this is the problem. As you can see here, I mean, I've taken a lot of things apart. I've actually looked at the I took all of this apart and traced all the wiring. I looked at let's see, I don't want this to fire up again. Is it going to fire up again on us? Yeah, it's going to try to fire again. I don't want that to happen. So we're going to shut that down. Go ahead and turn the gas off while we're working on it. Now that our exchanger is still warm, but it's not overheated. And we'll have nothing coming through now. So we'll be able to put our new motor in. Now, I don't know exactly how I'm going to go about this. This has got these kinds of terminals. It's got these little spade terminals. The brown wires are always for your capacitor. This is a ground wire, so this will go to the chassis of the squirrel cage, and then these will be your various speeds. This is a 4-speed. One of these will be common, and that should be the black, or the white, excuse me. That would be the white. The white's the common. So the black is the high, blue is the next, is medium high, red is medium, and gray is low. The reason you have different speeds and different circuits for those is because one of them will be, at least on my system, one of these is going to be used for the heat, and another one's going to be used for the cool in the summertime. And those will be on different circuits, and they'll run separately. All right, so it's looking like I'm going to have to put this bracket around the motor, and then the legs will attach to that. Okay, so I briefly just turned the unit back on and observed that the squirrel cage is actually going this way around. So if we're looking at the back of the motor, it's actually going this way, and I don't know if that means counterclockwise or clockwise, because I don't know which direction you're supposed to observe that from. I wish they would tell you, because I don't have a clue. I guess I could hook it up to power and start it up and let it run out here for a split second and see which way it's going. Or I could take it over on the bench at my house and put it on the variac actually and run it up slowly on that. I might actually do that. Yeah, let me go ahead and do that, and we'll come right back to this. Okay, we've got the blower motor out with the squirrel cage and everything still attached. We need to get this squirrel cage released from the motor itself. And over on this side there's a lock. There's a little lock bolt for that. Let's see. Don't know what size it is. Hopefully it's the flat side of this. It should be where the set screw goes onto, but it's not. It's on the round side. So what that's done probably is it's burred up the round side, and the round side is the side that needs to squeeze through the shaft. So hopefully we can even get it out. I had to go to the chiropractor today and have my back and my shoulder worked on. This is really the last thing I needed to be doing today, honestly. But the wife was cold, and so pretty much everything else has to be dropped. The chiropractor said I had bone spurs. He did an x-ray. He said I got bone spurs on my spine, my discs on my spine. So yay. Whoever put this son of a bitch in here cross-threaded the fucking thing. Because it can't be fucking simple. It's got to be some bullshit. It's always the way it is, isn't it? Alright, I'm going to have to go get a very large screwdriver, a large hefty one, and a hammer. When we get there fully. Why didn't I get WD-40 while I was out there? Why the f? Okay, on this motor design, this doesn't require any screw hardware to hold these brackets on. It's just this one round bracket that goes around the entire motor and cinches up with this bolt, and that holds all three of these mounting brackets on. I've actually got them out of place though. One of them. Yeah, just like that. There's a little notch that each one of those goes into. And let's see, is this one on there? Nope. Alright, now it is. Okay, so that's how it goes right there. The strap goes around, and the legs go on like so. And it actually looks like I'm going to have to do more than that. I'm going to have to put some self-tappers in it, maybe. That's unfortunate, too, because I'm going to have to make sure that this thing is centered. Now I gotta go find screws. Okay, found some hardware for this. Hopefully I got it centered correctly. It looks centered to me, so fingers crossed it's centered. Alright, now we gotta splice these new wires to these old wires. The reason I'm doing it this way is because I want to keep this connector right here. I need to look at the schematic because I'm not exactly sure which wires I need to use. Okay, so in the current setup, red is actually doing nothing. Over here on the junction box, the red wire that's coming up from this one is just terminating up there and doing nothing. It just stops. The blue is going to medium high, so this one definitely is being used. But inside the junction box, it's going to one of these red wires right here. It's tying to the red wire that's going up to the switch. So but the blue needs to go up there. And yes, I'm using wire nuts because it's going to save me time. And like I said, this way at least I will not have to, I won't have to change this out. I want to be able to use this. Okay, like I said, red is doing nothing in our current setup, so I'm just going to clip it flush to avoid confusion. Black is going to go to black. And our gray wire is the low, so that one is going to go to, that one's going to the purple, right? No, I'm wrong. Actually, the blue goes to the gray, and then purple goes to white. Purple is going to white, so that's the one that's always on, and that's the one that, because that's our always on hot wire. So is it only 3 wires then? Here we go. I'll get this back in here and I'll come back to you. Then we'll test it. Okay, here we go. Time to test this thing out. We had 2 wires again we're not using. These are the 2 speeds of the blower motor that are not going to be used, so I went ahead and taped those off so they won't hit anything. I also went ahead and hooked the switch back up. This is a solenoid triggered switch. It switches whenever it detects the fan is on, and it detects that through current on this white wire right here. So anytime there's current on the white wire, it triggers this switch, and that's for the humidifier that's on this unit on the other side. So definitely want to make sure I hook that back up. Let's give her a shot here and make sure we got, because I had to take this apart earlier and let's make sure everything is out of the way. Should probably go ahead also and should probably make some kind of effort to cover this solenoid back up, but I don't know. Actually, I'm going to leave it off because I don't want it to get stuck. I don't want that to get stuck, so I'll leave that off of there for now. Let's turn the gas on and we'll hit this. I think we're ready. Actually, you know what? Let me kill it for 1 second. Kill it for 1 second because I want to get these wires for the motor kind of back. I want them to be out of the way of the filter when I change the filter. So I want to make sure the fan just comes on down here first. So we'll turn the switch on. We've got power to the unit now. We'll give it a second. Once this fan comes on and I'm sure that it's on, that's when I'm going to put this door back on. Got heat. And hopefully this fan doesn't start kicking up any loud noises or any banging or anything like that. If it does, I'm going to be Johnny on the spot with the power switch. But it won't turn on until this switch right here, that middle position, that little notch right in the middle right there, gets to that second notch right there. So that notch, and then this one over here, those are the 3 that are settable on this fan limiter switch. Okay, we're past the first switch and almost to the second switch. That's when the fan should kick on down here. And with any luck, we won't have any problems. Okay, should kick on any second. There we go. And it is. It's doing a little bit more shimmying than I would like, if I'm honest. It's doing a little bit more shimmying than I would like. But I'll tell you what, I'm gonna, I don't know, I'm gonna, 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 I'm gonna I'm going to, whoa, what was that? Oh, that was a piece of something that went up in there. Damn it, piece of plastic. Shit. A little piece of plastic that went up in there. Hopefully it just gets burned up and doesn't get blown out anywhere on fire. Probably need to close this door up so that we know it's actually going to work. Let me go ahead and do that. Whoa. Yeah, you can see, yeah, this is way stronger. There we go. Okay. Is it going to switch off? Going up too high. I think it's going to switch off. Or no, wait, is it? Yeah, it did switch off. Alright, there goes the flame again. Okay, maybe now this time, because the fan has been running, this door has been on the entire time. Maybe this time there'll be enough airflow to keep that switch from tripping before the house warms up. Okay, there's the switch tripping again. I can tell the fan is still running though, down here. We should get flame any second now again. Okay. And we do. At this point, we just want to see whether or not the fan down here shuts itself off like it has been doing. We don't want it to shut itself off. Obviously, that was a problem, because if this fan down here shuts itself off before the house is up to temp, then it's not going to ever heat the house up. Okay, so I'm going to keep an eye on this for the next little bit, and I want to see if the fan shuts itself off before the house reaches temp, or if the thermostat actually shuts itself off, and then we'll know whether it's fixed. Okay, so it's been a little bit now, and this thing is cycling the way that it's supposed to, and the blower motor is remaining on the time that it's supposed to be on, so we've got this thing fixed. Okay, so here's the real final test. So what's happening right now is the blower motor down here is still on. This motor looks like it might have just shut down, but it's still spinning. The gas is off, and it's been off for a little bit because the thermostat has been satisfied, so it's no longer calling for heat. So what's happening right now is this the exchanger box is cooling down, and you can see it kind of cooling down here. So what we're going to watch for is when it gets to that bottom notch, if the fan shuts off at the bottom notch, because now it's running an entire cycle, then we know for sure this thing is fixed. So we'll give this a couple minutes, and it should shut off when it reaches that bottom notch. Yeah, you can see there is a little bit of a shimmy in this. You see how that's kind of shaking just a little bit. It's not that bad. I don't think it's any worse than it was when I started with the old motor. But still, if I ever take it out again, I'll keep that in mind, and I'll try to balance it a little bit better if I can. It'll just probably, prevent wear on everything over time, but I think right now I'm really happy with this the way it is at the moment. There we go. So switch is working, fan is working, everything's working. So yeah, that'll do it for this one. If you guys have enjoyed this video, and if you like videos like this where I just fix random stuff, that's what we do on this channel. We just fix random stuff, whether it's stuff we found on the curb or whether it's stuff like this, HVAC systems, you know, appliances, washers and dryers, things like that, then you're in the right place. Hit subscribe, and for now, we will see y'all later.